Hello everybody, and welcome to this video today in our YouTube channel. In today's video we shall be looking at how we can answer the question we have here on screen, which is based on curve sketching. So guys, please watch this video from start to finish, because by the end of this video you shall have a better understanding on the concept of curve sketching. So guys, good luck to all those who are taking mathematics, those who are taking further mathematics in their exams, especially those who are taking the Cameroon GCE at the advanced level, and those for the alternate level. Good luck to all of you. Good luck as well to those who will be writing their WAEC, their JAM, and so on. Good luck to all the Cambridge students, all the US students that are also taking their own exams. Good luck to all of you. Good luck to everybody taking mathematics as in general as an exam. So guys, please, just for a quick reminder, I would like to beg and plead on all of you watching this video today to please subscribe to the channel, so that you're going to have access to all our contents. And because subscribing to the channel, that is going to motivate me a lot. And please just make it a habit that each time you watch videos in this our channel, you must like them, because that does motivate me enough to produce more and more content. Please just press the like button beneath this video. It won't cost you much. It won't cost you anything, guys, anything. And subscribing as well to the channel will not cost you anything. There's no extra fee for it. Nothing, guys. Just press the subscribe button and like the video. That is going to help a lot. Thank you so much for doing so. So now let's dive straight into the video today. Okay, now guys, this is the question that we have here. We should consider a function f with representative curve defined by f of x equal to this. We should find the domain of f, and the next part, this is how it follows. So guys, let's start with the first part. The first part simply wants us to get the domain of f. Guys, we have to keep in mind that in this case, for the domain, where we are focused is simply the numerator. It's simply the denominator, sorry. So we are simply going to be looking at the square root of x squared minus 1. Now we have two things that we have to take care of, guys. We have two things that we have to take care of. So our first the first thing that we have to take care is that what should be under this numerator should not be 0, and what should be inside the square root should not be less than 0. So at the end result now, guys, we can establish that x squared minus 1, that has to be greater than 0. Why? Because if it is equal to 0, guys, we have a problem, because division by 0 is not allowed. Likewise, if it is less than 0, that is, if it's a negative number, we are going to have the square root of a negative number, which gives us what? A complex result, and it is still not allowed. So guys, all we care is that what x squared minus 1 should be greater than 0. If we simplify as the difference of two squares, guys, we are simply going to have our x minus 1 into x plus 1, that has to be greater than 0. So if we put it on the number line now and observe the signs, we are going to see that our domain is going to be from where? From negative infinitive, that's the open interval, from negative infinitive to negative 1 union. We start from 1 and we end at positive infinitive. Great. So guys, this is the domain of our function f. Alright, now the next part wants us to use the fact that f of x is this, as we have here, to evaluate the limit as x goes to negative infinitive and when x goes to positive infinitive. Okay guys, if we get the limit as x goes to negative infinitive of this function, guys, let's take note about this guy here. Let's take note about the absolute value of x. We should know that the absolute value of x, guys, is positive if and only if x is greater than or equal to 0, and it is negative if and only if x is less than 0. In this case, guys, x is tending towards negative infinitive, a number that is less than 0. So now the absolute value of x now in this case has to be what? Negative. So this is going to be what? Negative x, so that the x can cancel the negative x we have down. So we are going to have negative at the bottom here, and when x goes to negative infinitive, guys, everybody here goes to 0. This guy here goes 2 over x goes to 0. 1 over negative 1 over x squared goes to 0. So at the end result now, we are simply going to have our answer to be negative 1. Good. Now again guys, if we take a limit now as x now goes to positive infinity, that is it is going to x in this case is what, positive, right? So this guy becomes positive. The absolute value of x in this case becomes positive. So here is just x. The s can x, they can cancel from both the top and the bottom. They are going to cancel. This guy goes to 0, this guy goes to 0, this guy goes to 0. So we simply have 1 over the square root of 1, which that is going to give us 1. So now guys, we have taken the limit as x goes to negative infinity, and that when s goes to positive infinity. Now guys, we also have to get the limit as x goes to negative 1 from below, and the limit as when s goes to 1 from above. Though the equation did not say that, but we have to do so. We have to really investigate the curve fully. Great. So we are going to take the limit as x goes to negative 1 from below, guys. We will see that if we take a number that is less than negative 1 a bit, we can take negative 1.1 and put into all the x's, all of them, guys. We'll see that this guy will be going to, all we simply care is the sign, okay? Because when x is going towards negative 1 from below, keep in mind that negative 1 is what is an exception to the domain of f. So this was what we expect to have here is what, infinity. But is it positive or negative infinity, guys? The sign of what we have here determines if it is negative infinity or positive infinity. Great. So in this case, guys, we'll see that if we put it, we are going to have answers to be negative infinity. Again, guys, if you also take the limit as x goes to 1 from above, that is, you can choose any number that is less than, that is slightly less than 1, that is slightly greater than 1. You can take a number such as 1.1. If you plug it into all the x's, guys, you see that, and you observe the sign of this entire guy. Remember, we expect to have infinity, but is it positive or negative? So guys, if you put in everything, you expect to see an answer of negative infinity, guys. So now, since in the first case, guys, we took x was going towards negative infinity, guys, that's x is turning into an infinite value, then what, the resultant value we get is what, finite. Likewise, x here is turning into an infinite value, and the answer we have here is what, is a finite, right, which is 1. So we can conclude that the line y equal to negative 1 and y equal to 1 are what, are horizontal asymptotes. Likewise, x here was turning to x here was turning to a finite value, and the result we get is what, infinite. Likewise, x was turning to a finite value here, with the result we have is infinite. That therefore means that the line x equal to negative 1 and x equal to 1 are what, are vertical asymptotes. So this function definitely has 2 vertical and 2 horizontal asymptotes. Take note, guys. Okay, now the next part wants us to deduce the asymptotes of f. Now let's move on to the next slide and do that. So we are simply going to say our asymptotes are definitely going to be at the point when x is negative 1, x is 1, y is 1, and y to be negative 1. Great. So guys, those are the asymptotes of the curve we are looking for. Then now the next part is saying that we should find f prime of x and explain why the graph of y equals f of x has no turning points. Okay guys, let's go ahead to differentiate. F prime simply means we differentiate. So now we are going to apply the quotient rule, which says that we keep the bottom constant. That's bottom constant. The bottom was square root of x squared minus 1. Differentiating the top was x minus 2. So differentiating it is simply going to give us 1. Then minus the top constant. The top is x minus 2. Differentiating the bottom, we are simply going to have 1/2 into the square root of x squared minus 1 in the denominator. All that over the bottom squared, guys. Keep in mind that the bottom is what, square root of x squared minus 1. So if you square that, now the square simply goes away with the square root. We simply have x squared minus 1. So guys, this is the f prime of x. Don't make an attempt to simplify, because if you make an attempt to simplify and you end up having a wrong answer, you are going to score, you are not going to have the mark for this particular question. you won't have it. So take note, guys, don't simplify. The question did not specify that you should give your answer in a particular form. If the question has specified, that's when you'll be working towards that particular form to present your answer in. But in this case, the question did not specify, so this is enough. This is enough. Okay, now they want us to explain why the graph of y equals f of x has no turning point. So guys, as you all know, from turning point at turning points, let's try to verify if the graph actually has a turning point or not. So now for the turning point to exist, guys, we know that what f prime of x has to be 0. Good. Therefore that therefore implies that, guys, if we take f prime of x, which is what we have here, right, and we put that to 0, we are simply going to have the square root of x squared minus 1 minus x minus 2, all that over 2 into the square root of x squared minus 1 in the square root, all that on x squared minus 1, that is equal to 0. So guys, if this whole quantity is equal to 0, that therefore means that we can conclude that it is the top that is equal to 0, not the bottom. Okay, so the top in this case is 0. So in this case, guys, we are simply going to have the top, like I said, which is what, equal to 0. Now if we multiply all through by the LCM, which is simply 2 times the square root of x squared minus 1, we are simply going to have 2, because this square root multiply this guy to just gives you 2 into the interior, then minus now into x minus 2, that is equal to 0. So guys, if we simplify further, we are going to have our 2x squared minus x, that is equal to 0. So if we solve now, we are going to have x to be 1/2, or we have x to be 0. That's great, guys. That's awesome. Great. So we have x to be 1/2, or we have x to be 0. But guys, don't forget, keep in mind, guys, don't forget that the domain of f is from where? From negative infinity to -1 union. From where? From 1 to positive infinity. But guys, we can see that x equal to 1/2 is not a member of this domain, right? Because x equals to 1/2 simply lies from the region from -1 to 1. That is x equals 1/2 and x equals to 0. They are in the interval from -1 to 1, and that is where the curve does not lie. That's where the curve does not lie. So guys, we can say that clearly x equal to 1/2 and x equal to 0 do not belong to the domain of f. Hence we can conclude that the graph of y equal to f of x has no turning point. Great, guys. Guys, please, if you've not subscribed to the channel at this point in time, guys, please don't forget to subscribe to the channel and press the notification icon to get notified each time we have new videos. Guys, videos are available every day of the week. Every day videos are available, so you can't afford to miss. Just press the like button and subscribe to the channel and share it out with your friends, guys. Just make it a habit that each time you watch any video in this channel, you must like it and you must subscribe, because that's your own gift to me. And share that with your friends so that they can have access to good content like this that is going to help them in their own exam. Thank you very much, guys. Okay, now the next part wants us to find the coordinates of the points where the graph of y equals f of x crosses the coordinate axis. Okay, guys, let's move on to a next slide. All right. So now, to get the coordinates of the point where the graph crosses the coordinate axis, let's remind that this is the graph we have. This is the function f of x equals to this. So now, when y is 0, now guys, we are going to let y equal to 0. Why y equal to 0? Because the graph is going to cross the x-axis when y is 0. So now, when y is 0, guys, if this guy becomes 0, or f of x, because f of x, like I said, guys, we know it to be what? Y, right? Good. When y becomes 0, implies f of x is 0. We are simply going to have the top being equal to 0, so we are going to solve for that and have x to be 2. So the coordinates of the point now, guys, I was know that the curve will not cross the y-axis. It will not cross, and we have the coordinates to be 2, 0. Why would the curve not cross the y-axis, guys? Why? Because the curve is going to cross the y-axis when x is 0, right? And x cannot be 0. Keep in mind, guys, the domain is from -infinity to -1. You stop from -1 and you continue from 1. So 0 lies between where? 0 lies in the region from -1/2 to 1, and it is and it's the exact point where the curve does not exist. Okay, yeah. So, and if x becomes 0, what we are going to be having here is what the square root of -1, which is simply I, and it's complex. So the curve will not cross the y-axis. Good. So now, guys, so the next part wants us to get the equation of tangent. So guys, the equation of tangent has a form y equal to m into x minus x1 plus y1. And keep in mind that we want us to find the equation of tangent of the equation of tangent at the point where the curve meets the x-axis. So this is the point, the coordinate, when x is 0 and y, when x is 2 and y is 0. Good. So now, guys, the equation of tangent, like I said, has this point, but what is our gradient, guys? What is the value of m? Because m in this case is our gradient and we need it. Then x1 is simply the first x value, then y1 is simply the y value, which is 0. So guys, keep in mind that our m is the same like f prime of x at x equal to 2. Good. And don't forget that our f prime of x was what? The square root of x squared minus 1 minus x minus 2 of all over 2 square root of x squared minus 1, all that on x squared minus 1. So guys, now when x becomes 2, now, or at x equal to 2, we are going to have f prime of 2, which is equal to what? Root 3 by 3. Why that? Because if you put 2 into this guy, everything here becomes 0. If you put 2 here, you are going to have 2 squared, which is 4. 4 minus 1 is 3. We have the square root of 3. All that on we are going to have here as well is going to be 3. So this is our gradient, the value of m. So now the equation now, guys, if we simply plug in everything now, so we know that m is that. If we plug in everything, guys, we are going to have our y to be m is what? Root 3 by 3 into x minus our x1, guys. What's our x1? x1 in this case is 2. y1 is 0. That's why everything is blank. So guys, this is the equation of tangents that we needed to find. Great. Now the next part wants us to draw up the sine and the table of variation of the curve f. All right, guys, this is what we need. Now, guys, simply you should recap that the variation table simply comprises of what? The limits of x of f at the boundaries of its domain, and it also comprises of what? Turning points. But in this case, we don't have turning points, so we can omit that. It comprises of turning points if they are available. So now the first case, guys, we are going to have our x values. Then now what we need to put here, guys, is what? The sine of the gradient function. The sine of the gradient function. So we are going to have our f prime of x here. Then here now is going to be the shape of the curve, which is simply the function itself, f of x. So we are going to have f of x here. Good. Then now, what do we put here, guys? What exactly do we put here? So we are simply going to put negative infinitive at this point, because we need a behavior of the curve from between negative infinitive and from where we have -1. Then since the curve then from -1 to 1, now we know that the curve does not exist, right? Good. Then we also want to see the behavior of the curve now from 1 now up till positive infinitive. So this is what we have now. So now, guys, if we take any value between between -1 and infinitive, and we plug it into our function, guys, and we observe the sign, we'll see that the sign is going to work negative. We are going to have a negative sign. That therefore means that between negative infinitive and -1, the graph is what, or the curve is what? The curve is decreasing between negative infinitive and -1. It is decreasing. Then now we know that the curve does not exist between -1 and 1, right? So we can simply just shed that. Okay, we can simply just shed that, because the curve does not exist between these two regions. It does not exist. Then now, guys, if we take any number between 1 and positive infinitive and we put into our function, we'll see that the sign is going to be positive. If you take a number such as, let's just take 3. If you put 3 here, guys, if you put 3 into the original function, you'll see that the curve is going to what? The sign is going to be positive. So now it therefore means that the curve started decreasing from a point, from one point to a point, and increasing from one point to another point again. So now the curve is going to decrease from where? From -1 up to where, guys? Up to negative infinity. Then now it is going to increase again from that negative infinity, guys, and it's going to end at where? End at the point 1. Good. So guys, this is simply the behavior of the curve, guys. This is simply the variation table that tries to give you a picture of how the curve should look like and the behavior of that curve. So guys, this is the variation table. These are the signs. This is the behavior of the curve. Good. So now guys, let's move over to sketch the curve. Let's just move to sketch the curve. Okay, so guys, let's see if we can sketch the curve. So we are simply going to insert all the values we need. We need the asymptotes, that's at x equals to -1, x equals 1, y equals -1, and at y equal to 1. Good. Then now we also need the coordinates, the points where the curve is going to cut the x-axis when x is 2 and when y is 0. Good. So now we are going to draw our vertical line and we give that a name y. Then we draw our horizontal line, guys, and we give it a name x. Good. So now we are going to bring forward calibrations on the line. We are going to bring forward calibrations. We'll put this as 0. Then we put this one as 1 on the y-axis. Then we put this guy as -1 on the negative x-axis. Then we put this guy as -1 on the negative y-axis. Put this guy as 1 on the positive x-axis. Put this guy as 2 on the positive x-axis. So guys, I think I'm done with the labelings. Why is it so, guys? Because I'm inserting only the values in which I need. If you decide to label from 2 up till 5 or up to infinity, that's up to you. From 0 downwards to negative infinity, that's up to you. Likewise, these other zones, guys, it is up to you, but you're wasting your own time for nothing. So in this case, it is good to insert only the values that you need, only those that you need so well. And guys, after making for all these calibrations on the graph, all you need to do now is to start by inserting your asymptotes, guys. Insert your asymptotes. We have an asymptote as x equal to -1, right? So we are going to insert it here with the white line. Then at x equal to 1, so we also insert it here, guys, in white line. Then now at y equal to -1, we also have another asymptote, right? So we have it when y is -1, so we have it here. Then we also have it when y is 1. Good. So we have it here like this, guys. Please keep in mind most importantly that in the exam, for those writing the Cameroon GCE and other exams, you should know that these asymptotes are to be drawn with broken lines. Okay, always draw them with broken lines. Just that I was unable to draw it with the broken line, that's why I have solid lines, as you can see here. But on the exam, I will strongly recommend that you draw it with broken lines. Good. But if the asymptote is on the x-axis, no need to even draw anything, or on the y-axis, no need to draw anything. Good. So now, after bringing for the asymptotes, guys, we will see that the limit, in fact, we did that limit initially, right? That the limit as x was approaching -1 from the right, where was y going to? Y was going towards negative infinity. So it was coming towards negative infinity. So and we have the intercept to what? At x equal to 2, right? Good. So it's going to cross the x-axis, the y-axis, the x-axis at x equal to 2, right, when y is 0. Good. So this is what we are going to have. But guys, keep in mind that the graph in this case has crossed its horizontal asymptote, right? It has crossed its horizontal asymptote. So guys, don't be surprised that the graph has crossed its horizontal asymptote. Okay, just that it is supposed to respect it, but in some cases it can cross the asymptote. Okay, yeah, so in this case it has crossed, and there's no big deal about that. But while it is crossing this horizontal asymptote, it is respecting the vertical asymptote this way, and it is also respecting the horizontal asymptote up here. Okay, so it is respecting it, but in this case it had no choice but to cross this guy, because the graph cannot be hanging somewhere. But it is going to come as closer to this vertical asymptote, but it will never touch it. Good. So guys, what you can deduce is that a graph can cross its horizontal asymptote conveniently. Okay, it can cross it if it is necessary. It can cross it if necessary. So a graph could cross an asymptote, but a graph will not. If a graph is going closer and closer, it will not even touch nor cross. But a graph can freely cross its asymptote conveniently. Good. It can easily cross its asymptote, particularly its horizontal asymptote. Good. So now guys, likewise we can see that the limit as x was coming towards 1 from the right hand side, y was going towards negative infinity. That's why the graph has this shape. Then now, as the limit as x was coming towards negative 1 from the left hand side, where was y going to? Y was going towards negative infinity. So we are going to have our curve in this direction. Good. So it is going to respect this horizontal, this asymptote this way. It is going to respect it so well. Then it will also respect the vertical guy asymptote. So it's going to come closer to it, but you never touch it. Great. So guys, this is the curve of y equals f of x. So we can simply just label that as a curve of y equals to f of x. Good. So guys, this is how the curve looks like. Guys, please don't forget to like the video, because that does motivate me to produce more content for you. Subscribe to the channel if you've not done so, and turn on the notification icon to get notified each time we have videos. Check out the channel guys, every day of the week, every day we upload new contents. So guys, don't forget to share the video with your friends. Like I said, subscribe and like the video. Thank you very much, and have a blessed day.